Sure.
Okay, thanks, Andriy, for making it. I have your books with me, by the way. Uh,
Oh,
Here you go.
wow, cool. How do you find it?
Quite interesting. Haven't finished it. I go from page to page, not really following a sequence. I bought the first one already as well a couple of years back. So great to have you here. Maybe just first question, Andriy. How do you catch up with all the news? There's so much going on.
Well, yeah, well, I usually trust my X or X Twitter bubble. So, there is this home tab where X shows you recommended tweets. So if something important happens, I read about it. Otherwise, I also work on my newsletter. So
Yeah.
uh, for example, I like the recommended articles on my phone. On my phone I have Chrome,
Yeah.
and when you close all the tabs on your mobile Chrome, it shows you kind of articles that you might be interested in, and they are tailored to your browser history. I find it a little bit. Um, Inconvenient that it only works on mobile, so I cannot have the same feed of recommended articles on desktop. I Googled it, and people say, yeah, it's only on Chrome on the mobile in the mobile version of Chrome. But I really like the quality of recommendations. I don't know why Google decided to do it this way.
All right.
And finally, there is Reddit. So I did this machine learning community, machine learning subreddit. So
Yeah.
I read it once a week. Yeah. So these are my major sources.
And what are your current areas of focus? What are you following these days? What is interesting?
Well, I try to find something real, because there is a lot of hype and like claims, big claims. Okay, it's a game changer,
Yeah, I
and
saw you. I saw your post. Yes.
yeah. So I try to find something real in this, and probably uh, the thing that impressed me recently was this model from Google, where you can
Mm.
edit images by just giving text requests
Yeah.
in a chat format. Um, I think why it was important is because the model is truly multimodal. So the model can see, the model can read, it can write, and it can draw. So previously, for example, let's say if you used image generation in ChatGPT or in Grok, it was a separate model that was called
Mm.
to generate images, so there were no consistency between the calls. So
Mhm.
you ask for some specific design, it draws it, and then you say, okay, change this to that, and it draws a totally different image without any direct reference to the previous one. Just recently, OpenAI released their version of it, and
Mm.
I also find it quite impressive in quality.
Mm.
Well, impressive compared to what we saw in the past. Of course, there is a lot of issues of consistency. For example, it's much better in text than all previous models. It can really generate a diagram
Mm.
that looks like a diagram, but when you read the diagram, it's total nonsense. So it still
Yeah.
doesn't understand.
Okay.
Like for example, I asked for the transformer
Mhm.
diagram,
I
and
saw that. Yeah, I saw that.
yeah, and it really, drew multiple blocks of transformer architecture, but their order and what's inside and how they're connected, it was all wrong.
Yeah, it was the wrong direction of the
Yeah,
hour.
wrong direction, arrows pointing to nowhere. Some people also asked it to generate a multi-layer perceptron,
Yeah.
and it couldn't manage to connect all units to all units.
Okay.
Like for it, well, it's normal. Like this is how these models usually operate. They try to reproduce patterns and they are punished for patterns reproduced not exactly,
Mm.
but they are not punished, like, okay, this is totally wrong, you should do it this way. They don't do it. They just say, well, if you drew 5 lines out of 7, well, I will give you the penalty 5 out of 7. So the
Yeah.
model sees that, oh, okay, so I even if I am wrong, but I'm close to the
It's
correct
it's
result.
almost okay.
It's okay, yeah. So this is not how, of course, we would tolerate from a human being. So either
Yeah.
the human being understands how a multi-layer perceptron works, or they don't. There is no person, I think, in the world who would understand it 70%, and the difference would be that they don't know that they should connect
Yeah.
all units to all units. So yeah, so these models don't think of, unfortunately, but still impressive in terms of progress in image quality, in the text. For example, text is very much consistent. Not always. Sometimes
Mm. Mm.
letters aren't correct. Sometimes they're missing. But overall, it's an improvement. Yeah.
Where do you see LLMs in coding? There's a lot of hype around vibe coding since last
Yeah.
month, but
Yeah, this is actually one of the directions in which I think LLMs has the
mm,
highest potential,
mm,
especially thanks to the recent introduction of GRPO algorithm by DeepSeek.
mm,
This reinforcement learning algorithm where you can assign a reward for a correct result.
mm,
Uh, and for example, this is how they fine-tuned their R1 model to reason, because they assigned a reward for the presence of the reasoning tag, and they assigned a reward for the presence of the answer tag. And if the answer was exactly as they had in their ground truth, they gave the reward, let's say, of 1, and if it wasn't, they gave the reward of 0. But still,
mm,
the mere presence of these two tags gave a model a reward. So the model still persisted in generating those chain of thoughts, trying to
mm,
gather a higher reward. So this is well, this was very strong result, and now you see we have a new wave of models that are state of the art for math, coding, and overall reasoning. This is cool. So for coding specifically, I think what is again, I think we will see even better coding models, because
mm,
previously, if you wanted to create a better coding model, you would just need more code. So you draw everything you can from GitHub, from all previous repository that now probably abandoned, and so on.
yeah,
But eventually, everyone exhausted their sources, so everyone has the same amount of
yeah,
code.
yeah,
But now, with reinforcement learning, you can reuse the same sources multiple times. How is that? In my opinion, how they do it, and I saw some papers that confirm my opinion, is that what you do is that you let's say you take a whole repository,
mm,
and let's assume that it fits in the context, and Google currently, I think, supports at least 1 million token context, which is a lot, probably not enough to, for very large projects, but even if you take, some module from an
mm,
existing
yeah,
project.
mm,
So you take this module, you take all of its sources,
mm,
and you hide only one, let's say, function or one class.
Mm-hmm.
And you replace the hidden function or class with a verbal description of what it should do. And this
Mm-hmm.
verbal description also comes from an LLM. So you just show this whole bunch of code to an LLM, and you say, for this class, what exactly does it do? Or you can even ask for a doc string, okay, generated doc string for this class, or maybe
Yeah.
it's already there.
Mm-hmm.
So you hide this specific class or function, and then you ask an LLM to generate its content based on this verbal description.
Mm-hmm.
And then once it's generated, you compile the full, compile or build the full project. And if all the well, if it builds, if it compiles, and if all unit tests or whatever kind of tests the project has pass,
Mm-hmm.
then you say it was a correct generation and your reward is 1. If it fails, your reward is 0, or can be some in between reward for some properties. So in this case, you can reuse one project many times. You just hide different things
Mm-hmm.
and you rebuild and you see if it works. Of course, it will take a lot of compute just to build, verify, uh, propagate reward, build, verify, propagate reward. So it will be costly to train. But again, given that these companies still have billions of dollars of investments that they have received during the last 2 years, I think they can afford it, and this will be a huge step forward. Then will it, because some people, and myself included, I'm wondering, because this approach theoretically can lead to LLMs actually inventing new code.
Mm-hmm.
You hide a bunch of code, you don't say exactly what should be inside, and if it's wrong, you give it a 0 reward. So eventually the model will try to generate different stuff.
Yeah.
So trying to get this maximum reward. So will this different stuff be sufficiently different from what was actually in this code base? This
Yeah.
is a big open question. Theoretically, it can be because in reinforcement learning, you don't insist, on repeating the same tokens as you do in supervised fine tuning. But I'm still thinking that it will still try to use the knowledge gathered from other
Mm-hmm.
algorithms, other pieces of code from other projects, because you still start with this pre-training for predicting the next token.
Mm-hmm.
So like the chance that the model will generate something entirely different, something like new and groundbreaking, probably it exists, but I think it's quite tiny. It's much simpler to the model to just generate this code based on what it has seen in other projects, or even in this same project, because when you pre-train, you pre-train it on everything. So it's kind of if you hide this specific project from pre-training, it becomes difficult to, like, in this case, you must have as many versions of the model as you have repositories. So like I don't think that it will ever scale. If, let's say you have hundreds millions of repositories and you don't want the model to be pre-trained on some of them. So you have a version of the model not pre-trained on this, but pre-trained on all others. Then the second version not pre-trained on that, but pre-trained on all others. So I don't know how it will work. So yeah, so there is chance that this model will actually generate something new, and it will be cool. I would be really happy to see such a result. But so far, I think the model will just reproduce the same code that it has seen elsewhere. But given the fact that you actually force it to find the solution by itself, I think it will be much more resourceful when you use it interactively and you say, okay, well, I
Oh,
want
wow.
you to generate this function. So the model will not just use full reproduction from the training data, but it will use its gained ability to figure it out.
But that's almost like general intelligence, or that's a step towards general
Yes,
intelligence,
well,
right? Or
yes,
not?
it's a step in this direction in the sense that I think this is how uh, how they call it, AGI,
AGI, general,
artificial general intelligence. Yeah.
yeah.
So I think it would be a step in this direction. The problem is that we as humans, we receive these rewards from inside. Okay, so you feel that you succeeded. You feel that you are frustrated. You kind of just feel you want to do this.
Mm-hmm.
And we don't know why some people feel something in some cases and others don't. So
Mm-hmm.
there are people who always push the limits, always are out of their comfort zone.
Yeah.
Uh, Others are frustrated no matter what they do. They never satisfied. Others just are happy being and
Mm.
not doing anything. So there are some humans who get this reward, and it comes from the inside. And this reward make of them people who are more like smarter, better experts.
Mm-hmm.
Um,
Yeah, they have like a subconscious motivation to.
yeah, so there is already something in us
Mm.
that makes this reinforcement learning
Mm.
working
Mm-hmm.
work. And when you build a machine, so this reward comes from the designer of the experiment. And in our case with GRPO, we have this reward for accurate math problem
Mm.
solution. We have this reward for code that builds. And probably we also have the reward for, if the logic is correct, there are verifiers of logic, so they can say, yes, this is true, this is false. But for everything else, we have nothing.
Mm.
So how do you define the reward for the model that gives you an answer on some historical question, that gives you an answer on some medical question?
Mm.
There like in healthcare and in treating people diseases, there is rarely like one right answer.
Mm.
So like, and even if it was one right answer, uh, like you can try some treatment and the person died anywhere. So did the person die because of your treatment or it was something else? And we don't always know this for sure. So how do we reward or penalize a model in this case? This is a very big open question. So like for scientists, they are rewarded by publishing their paper. So they're
Mm.
motivated by this. If they write a good quality paper, if it's really some substantial result, other scientists will read it in a peer review and say, yes, we agree that it should be published.
Mm.
And when the scientist receives this acceptance, they are super happy and they say, oh my, yes, I am on the right path, I will continue. How do you do it with a model during training? Well, you will not wait for the model to write an article, then someone will accept it, and then you give it a reward. Imagine how slow it will be.
But related question then. Do you think that we need something else than transformers then to achieve some kind of, I mean, is that the end of the journey? Probably not, right? But do you
Mhm.
see something else coming up or not yet? New architecture, or that's too early?
Well, this is the a $1 billion question
No, I
because
know, but okay.
yeah. So if you look at the history of AI as a scientific domain,
Mm.
you will see that there were some periods of increased advancement speed,
Mm.
and there were period of nothing, and those periods sometimes are referred to as AI winters.
Yeah, in the
So
90s, I remember myself, right?
yeah.
Yeah.
Yeah. Well, I when I started my PhD, it was like just the beginning of growth after a winter. And my research advisor, he just started to build his team once again because he lost everyone during the previous one.
Mm,
So yeah, so there was these periods of excitements, and the excitements came from some breakthroughs that
mm,
actually were practically very significant. For example, let's say um, there were decision trees, okay, and for some time people thought that maybe they can be improved somehow.
mm,
They were still weak because they could easily overfit and so on. But then suddenly random forests and then
mm,
gradient boosting and overall the boosting as an approach. So you take multiple trees, you combine them, and suddenly you have a result very much stronger than one individual tree. And the idea is quite simple, but it took many years, decades before it was
mm,
tested, invented, and tested. So like or for example, support vector machines.
mm,
Uh, so again, the idea is simple. More like perceptron was invented in the 50s, but support vector machines with the introduction of kernels
mm,
made them
mm,
work for non-linearly
mm, yeah,
separatable domains. And again, it was a huge breakthrough. And people started to think that you can just, put more research in
mm,
boosting, put more research in this vector machines, maybe find some better kernels and so on. But it didn't give anything substantially. Yeah, the speed, the scale
mm,
increased, but the intelligence, if we can call it this way, remained more or less the same. So this breakthrough, they weren't kind of, designed like, okay, let's invent some new approach. We need
mhm,
it. And people start really like thinking hard and
mm,
money goes in. And yes, we have a totally new paradigm, like from
mm,
trees to kernels, and then neural networks of with just one layer to neural
mm,
networks with multiple layers. So it,
mm,
it was it was all kind of a chance. And then once the chance occurred, then money and excitement from the
yeah,
researchers pushed it
push.
to something big. So this chance, I don't know how we can program it. So I don't think that you can just say, okay, let's create this chance, let's pour money and wait for it. I just
But
don't think that it works this way. It's like any science. Like, for example, you cannot just throw a lot of money into creation of cold fusion, so that which is
mm,
stable
mm,
and not just stable, but also produce more energy than it generates, just because you want it and just because you have enough money. Otherwise, we would already have it. So these chances, I think they like I'm an agnostic, but I think that these chances might fall from space.
yeah, yeah, sure, I understand.
The time is right. So it might happen tomorrow, but it might happen in 20, 50, 70 years. No one knows.
So at the moment, we don't see any. This is more like an evolution of transformer architecture with reinforcement learning and so on and so on. But do we see like are the LLMs or the models going to be bigger and bigger, or are they going to be more specialized or smaller? Or what is the trend?
Well, this question I ask myself all the time, and every time I see some small-ish. By the way, the definition of what small is changed
Yeah.
a lot. This is why, for example, when I looked for the title of my book, I didn't use large. So the 100 page.
Oh yeah, right.
language
That's
model
true.
book. So
Yes.
I didn't put large in it, and I risked having less sales because of it. Because people sometimes look for large language models. Maybe they don't find my book this way,
Mhm.
but I didn't want to put large because this notion changes all the time. And when it started 2 years ago, a 7 billion model was considered large. And let's
Mhm.
say a model of 1 billion or less were considered small. But today, they say, oh, even a small model like 20 billion parameters can do it. Well, 20 billion,
Was
you cannot fine tune it well on one top GPU like H100. Fine tuning 20 billion, maybe you will be able to do it in lower precision with very short context. So no, it's a huge model if it doesn't fit on H100. So yeah, those smaller model, of course, many people dream about a breakthrough there because if you have a strong model that fits on one GPU, or at least you can come comfortably fine tune it on a node of eight H100 with the long context, the maximum context that you want, because context is not, it's not just how model can operate. The context, actually, it's a lot of memory. So if you want to fine tune your model on, let's say, extracting something from large documents, you need to fit all these large documents in your input. And if it's, let's say, 100,000 tokens, each token, it's an embedding. So it's 100,000 embeddings that you need to put on the GPU, and it might take the entire memory of the GPU just for the context alone. So you don't have space for the model, you don't have space for gradients, so you cannot really train it. So of course, people really want small models like this. But so far, I think they are become more and more kind of intelligent, so they can beat some benchmarks better than previous models of this size, but they are very poor in facts. So if you ask it about something like what this is, or when this was, or who is this person, it will generate anything but truth. And this is problematic because you cannot, because like when you use an LLM, usually, well, at least not today, maybe tomorrow or this year, they will invent some kind of a dispatcher that will decide which model should handle which query. And if it sees that it's about math, it will send it to a larger model. If it sees that it's about just some basic logic, it will send it to a smaller model. Maybe it will influence the cost of it, like you pay less if it's smaller model answer, and you pay more if it's larger. But overall, like, you cannot just use it alone, or you can put it on your local device, like on your phone, and you never sure. Like, people say, oh, if it's it's how do you call it, apocalypse, like zombie apocalypse, and there is no internet, no connection whatsoever, but I have my phone and I have this model on it, and it will explain to me how to build, I don't know, some device that we lost because the civilization is over, or how to build a dynamite, or how to how to fish, and so on. So sometimes it will actually explain to you the right thing, but sometimes it will just generate like a totally wrong explanation. You will try and you will kill yourself, because like it will say, mix this liquid with this liquid in this proportion. So you do it, there is an explosion, you're dead. So yeah, there is a risk with this
But
model.
today we try to compensate all this with RAG and agents and put multiple models uh, together to have some models reviewing what the others are doing and things like that, right? That's a way to mitigate the problem with.
Yes,
what you mentioned.
RAG reduces hallucinations,
Mm,
but RAG doesn't help the model to know something.
mm,
I mean, in the sense that, how to tell it? So RAG on one hand is beneficial because the
mm,
model can take the actual text from some actual document, and if this document is reliable,
mm,
the output of the LLM will be reliable
mm,
ish, because well there is still some person some chance of error, but
mm,
RAG makes the model incapable of generalizing
mm,
and kind of
mm,
combining multiple capabilities together. Like, for
mm,
example, when you ask a question directly, the model will answer by fusioning a lot
mm,
of different, documents from its training data implicitly to give you the final answer. And
mm,
sometimes this fusion creates a sort of a synergy where none of the original sources contain the response, but when you combine them, it gives you your answer. But with RAG, you make the model incapable of doing it. You just say, this is the information that you can use. You cannot use any other information. So
mm.
you reduce the model
Okay.
to a kind
Mm,
of a paraphraser. That's it. So
yes.
if your knowledge base is infinite, it contains everything. Of course, RAG is a solution to everything, but we don't
Okay.
have such a knowledge base. So usually your knowledge base is much smaller than the training data that was used to train the model. So by insisting on repeating only what
Okay.
RAG provides you, you reduce the range of capabilities that the models can provide you. It's a trade-off. So if you don't
Mm,
want to make any errors, it's like in a normal machine learning, like supervised learning. If you don't
mm,
want the model to make any errors, there is this decision threshold,
for sure.
and it
Mm,
decides between precision and recall. So
mm.
if you want the highest precision possible, you can have it, but you will only have it like for a tiny fraction of examples. But if you
Sometimes it's
want,
okay. Sometimes it's okay for
well,
regulatory
like it
industries,
depends on your use case. So
regulated industries. Mm.
RAG, it's the use case. Sometimes it's appropriate, sometimes less, yeah, but it's not a solution to hallucinations, and it's not really an extension of model capabilities.
Maybe last question, because I could stay with you for hours, right? But I'm sure you have other things to do. But
Yeah, go on.
um, what's your view on the agents? How does it help us? And how
Well,
did you see agents in production, for example?
Well, as someone who made my PhD in agents and multi-agent systems in 20 between 2005 and 2010,
Okay.
uh, I actually worked on multi-agent on reinforcement learning, multi-agent reinforcement
Mm,
learning, computational game theory. So there is a large and very solid body of research and science
mm,
around agents. So agents have definitions for scientists. So
okay.
if you open the book from Russell and Norvig, Artificial
I have
Intelligence.
it. I have it here.
Well, I think it's chapter 2. So if
Mm,
you open this chapter 2 and you start reading about agents, you will have a definition of what an
mm,
agent is.
mm,
So agent usually is defined as an actor in an environment,
mm.
and it first of all, it has its goals, okay? And it has its intentions, and it has its capabilities, and it has actuators that can change the
Mm.
state of the environment, and it can receive the feedback from the environment, update its internal state, and it executes actions in with the goal of reaching its goal. Well, if I can tell it this way.
Yeah.
So now what people call agents today,
Mm,
this so I know that our dictionary or vocabulary of English is limited. Okay, so you cannot invent words indefinitely. So there was the word for agent, and it wasn't used according to these people who learned about AI just 2 years ago. So they used this word. Okay, they decided to call an LLM which you prompted with some kind of system prompt that says you are a helpful agent. You must do everything you can to solve this particular problem. Now solve it. So, like, it's a very naive way of defining an agent. So just because you told to an LLM that it should solve this problem, it doesn't mean that the LLM is capable of doing it. It doesn't, even if it's capable of doing it in some contexts that you can then share online and say, look how my agent solved this problem, it will fail in other contexts. And why it happens is because, sorry, because LLMs were trained on text data. So if the text data contained something resembling the solution for the problem you want your agent to apply, it will solve it likely. But if those texts contain nothing, it will fail miserably. So it's not an well, for it to be an agent, it must understand, well, not it must understand, but the designer of the agent must understand that this agent will live in some specific environment with some specific properties. So when the agent execute action A, it can receive feedback of form B. If the agent execute an action C, it will receive the feedback in form D or XYZ. So usually this environment has some properties, and if the agent, for example, should learn, the agent will have an algorithm that was designed for this specific environment and for the capabilities. I'm sorry. And for the capabilities of this environment. So when you just put an LLM in the wild, nothing of this is respected. So you don't know what this environment is. You really don't know what kind of actions the LLM will try to execute, and you don't know what kind of feedback. I'm sorry.
No worries.
You can cut it off then. So you don't know what kind of feedback the LLM will receive. So basically, you don't know anything about your agent and the environment in which you put it. So it's a kind of like you just throw something there and you say, okay, do something for me. This is not an agent. This is not scientific because there is no optimization. Usually in science and in AI, you see it all the time. We optimize for something. So we define what's the outcome we expect, and we define a function, like for example, like a loss function or reward function that reflects how well, how close we are. But in these agents, they call agents, they don't do it. You just type some text and you hope, you cross fingers that something will be done. So yes, well, in some cases, such agent can be effective, and these cases are where they work with the data that looks very much as the data that was used to train them. So this is why most of the, if not all, examples of agents is either around coding or around information synthesis. Like I will go online, I will find this, I will find that, and then
I
I
book a travel or I do something like that, right?
yes, yeah. So yeah, but again, if you look really closely at these use cases, probably you don't need agents. For example, they say, "Oh, my agent will crawl the web and it will find some articles and inform my user about some new information, and I will synthesize it for them." But why do you need to crawl? People have search engines, and we have been using search engines for decades. So if you want to stay aware of all new stuff on some topic, just, have a cron that will execute a search based on some predefined queries that you care about. For example, you care about, I don't know, you work for IBM, and you want to know everything that happens around IBM, what people say, what clients say, what competitors do. So you can define queries like IBM and some competitors, I don't know, Microsoft, Amazon, and so on. And then once a day or once a week, you execute several searches using a normal search engine. You pull all the documents that it returns. You remove everything that you already know. I mean, the documents that you have already seen. Then you might think about some kind of filtering and remove probably documents not of the kind that you want, but because, well, people mention IBM in different contexts, so you can have some classifier that says this is not the kind of documents I care about. And in the end, you will end up with maybe 100 documents every day to synthesize. And then you put these documents in a LLM context, and you ask it, write me a summary of it, or extract all numbers that I care about. For example, I care about like revenues, I care about losses, I care about investments, and send me this in this format. Why do you need agents? It's all, it's just a step-by-step approach based on a search engine.
Yeah, so we have to look at the use case first, right? Not at the technology first. That's that's something
Yeah,
we do.
this notion of, agent kind of surfing the web, it sounds cool, like a science fiction, but how exactly this surfing happens? Kind of it jumps from one website to another and sits on this website and looks like you cannot, sit on a website. You download the page and you look at it. So you sit at the same place as you always
Yeah.
where you always sit, and the data comes to you.
But if you define well-defined guardrails to an agent, well-defined tasks, well-defined objectives, and that could be useful, right? Uh,
Well, what you define and what the agent will do, it's two different things.
mm,
Because like we kind of communicate with a machine with an ambiguous interface, which we call human natural human
Language.
language.
Mm,
So you might think that you expressed what you want clearly. You can even ask the agent to repeat,
mm,
and it will repeat it, and you will say, "Oh, good one. It's correct." But in reality, when it will actually act, it might act unpredictably. For example, I can give you an example, and it's really simple example that shows that agents cannot really be trusted because LLMs at the basis cannot. So I work currently. I work on translating my book from English to French, and I know French, but I, of course, I don't know it well enough so that I can, write from scratch beautiful sentences that
mm.
would be of book quality. So of course I opt for using an LLM to help me with the translation. And my first idea was, wow, this is really cool because I already have a glossary
Mhm.
of like for this French term, this is the English term. For this French, this is the English, and this is cool. Why? Because with the glossary, like you will have a consistent translation. So the same English term throughout the book will be translated the same way because like French has so many words for the same English one, like any like any language. Because in English there is just one word for something, but in Russian or French there can be 10. Okay,
Mm.
so I was like, this is really cool because we have this long context. I can put my glossary there and I can instruct it like if you translate, use the glossary for all English words that you
Mm.
encounter. And it didn't work. So like you can give it maybe a short paragraph or 3 or 4 paragraphs and it will translate it. But one of the terms wasn't translated according to the glossary. And I say in the subsequent prompt, you were supposed to translate this term according to the glossary, and it regenerates the translation, and now this piece is translated, but now the term is in bold. And I write, you are not supposed to put terms in bold if they weren't in bold in the original. Okay, regenerates, and now this one not in bold, and all others are no longer in bold. So if you cannot trust it for such obvious tasks, and I put all the requests in my prompt. I said, do not add annotations, do not remove annotations, translate only according to the glossary, and so on. It was all there in the initial prompt. And even starting from the very first translation, some of these requirements were violated. And I talk about the most capable models. Like I tested, let's say, O3 Mini from OpenAI, a reasoning model. I tested Grok, I tested Gemini. None of them are capable of producing a translation of 3, 4, 5 paragraphs without violating any of the conditions. And so, as I said, like these conditions, you might say, well, not a big deal, you will fix it. Yes, I will. But if these conditions are for some mission critical performance, any violation of them can lead to World War III or whatever. So no, I would not really call them agents, and I would not trust them to do work without human in the loop. There is always should be some human knowing exactly what it's supposed to be done and being able to recognize errors when they happen.
Great. Thank you so much for your time. We could continue like that for the whole evening.
Yeah.
But I'm sure you have lots of things to do. But frankly, anyway, I'm gonna upload the recording on YouTube and I'll let you know. I do a summary as well. But it was fantastic talking to you. Thanks so much. I'm learning every day. I learn a lot.
Thanks for having me, Patrick.
Thank you so much, Andriy.
Once it's online, I will
It was really fun. Thanks so much.
Thank you.
Bye-bye.
Take care.
Merci
Bye.
beaucoup.
Je t'en prie.